Hello. Yeah, so the last talk with the Dualite was great. Mine is little boring, you would say. Uh, so, with, okay. So the topic for my talk is next gen file storage in browser using OPFS with React. So in the current scenario, like if we want to store files in our for our web applications, we always used to think of a database or a server where we can store, we can get it by an endpoint and so on. But what if I tell you, like, the browsers nowadays has evolved so much that we can store a lot of data, not as much as we can store in data, but typically a good amount of data in our in our browser only, so that we can get rid of the latency with the databases, servers, and so on. So yeah, so so if we talk about the evaluation of web, so in Web 1, cookies were introduced. Basically, in Web 1, we have only the static sites, not much of interaction and so on. So cookies was a great storage solution, a good step towards storage in browser. But the problem with cookies is it has a limited storage. Maybe we get around 4 KB of storage per cookie. And there are security concerns. We have to send it via HTTP again and again. So and as we progress to Web 2 in 2010, 6, 8, 10, W3C introduced local storages and in session storages and IndexedDB. Basically, local storage give us a more storage for our for data in our web browsers. But the problem is it is a synchronous API. We cannot store much and it blocks our main thread and stuff like that. Session storage is also good, but it is persistent. It is not persistent. Basically, if you close a tab and reopen it again, so it will, all your data will be gone. Plus, session storage has a limited storage as well. And to solve this problem, we have a very good solution, which is IndexedDB, which is right now the most popular storage solution in the browser. Basically, IndexedDB provides you an asynchronous API to store your data. It has more storage compared to all of the other solutions. Like, it depends on browsers, like what storage quota they get. So in Chrome, it's approximately 80% of your available disk storage. Um, yeah, it's in the next slides. So as we progress to Web3, we are moving towards decentralization, removing the database layer and privacy stuff in, like, I have to keep my stuff in my local browser only. So there comes OPFS, which stands for Origin Private File System. It's a file system which is private to your origin, and you can, it's basically if I talk about Windows, so the C directory is the root directory, and you can keep on creating folders inside it, and you can keep adding files. You can go as deep as you can. So this is what OPFS is. You can create files, folders inside it, and it's totally uh, cannot be accessed by other origin. Okay. So to keep this talk like a little interactive, okay. So let's build a to-do app in React. Okay. So the requirement is it has to, like, do all the to-do stuff, create to-do, mark to-do as done, delete. So one thing, there will be no server involved. We have to keep all the data locally, and we need to ensure that the data will persist if we close the tab and reopen our web again. So, like, any solutions you have in mind, like how we can achieve this? Anyone? Local storage is one. IndexedDB. So yeah, those two are good solutions. So if I talk about the implementation of local storage, like, mostly we have no how local storage works. So basically, we get a local storage window API, and we have get item as well as set item in it, and we pass a key, and with that key, we have to pass a stringified value to the storage. So this will save in your browser. So if you want, we can access the local storage inside this developer tools, if you go inside application, here is the local storage tab. You can see all the local storage this docs.google is storing right now. Yeah, so this is one local storage approach. And when we go to IndexDB, so basically IndexDB is a key value storage kind of system. It's a NoSQL database. You can think, you can relate with that. We have to create a database inside our for our application, and then an object store corresponding to that database. And this object store is like we cannot change it again and again. It's only at the time of database creation. We can insert stuff, but we cannot like delete that object storage, and we cannot create a new object storage. So everything has to be in this particular function only if you have to create an object store. So same thing, we are doing this at the time of like in our on a component mount, we can get all the to-dos which are stored in our IndexDB, and we can like put the to-dos whenever the to-do is changed on the use effect dependency array. So, so for this IndexDB, let's go to application tab. You can find the IndexDB right here. So these are all databases. This docs error is a database, Google Docs is a database, and inside the databases we have object stores. So these are basically a key value structure. So if um, I have a demo application, if you want to see. So basically, if you store anything and you can add it, so it will go inside your IndexDB. So basically, this is the to do. This is the one I have added right now. So it's basically a key and a value corresponding to it, which is JSON, which is an object we can store in here. Similarly, any other solutions anybody have in mind? Okay, so what if I give another like a requirement to this application? So we have to store a media file corresponding to a to-do item for, let's say, edit context, or maybe anything. So how we gonna proceed with this? Because local storage is not a solution here, because it has a limited memory and we have to serialize the data to store. So one solution is IndexDB for sure. IndexDB is a great storage solution, as I said, and we can store files in it. But the question is, should we store files in IndexDB? And the answer to it is no, we should not store. IndexDB is not meant for file read and write operation. If you want to store files in IndexDB, we can, but the page will lag. We will have performance issues and everything. We cannot like fastly read the file, manipulate it, and then keep it back. Same stuff. So here comes the OPFS approach. So the same analogy. For Windows, we get a C directory, which is the root directory of our project. To get the root directory of our origin, for our OPFS, we have to use this navigator API from our browser, and navigator.storage.get directory will get you a top level folder location. Here we say it as a file handle. This root is a top level directory handle, and with every directory handle you get a file handle function. We can get a file handle, we can create a file with that, and we can go on recursively if you want. There's another get directory handle, which if I run this navigator.storage.get directory instead of to navigator, if I run it to root, then I can go nest inside my OPFS. So here I am doing the same thing. So IndexDB, the drawback of IndexDB is we cannot store files. So we can use file storage in OPFS, and we'll still use IndexDB for our normal JSON stuff and everything. So what my idea was here, like I'll store the file in OPFS, I'll get the path, and I'll store the path inside my IndexDB. So whenever I reload the page again, I'll iterate to my JSON in the IndexDB, I get the file path, I get the file from the OPFS itself. So you can see this media.id is nothing but my file path. I'm going to a root directory, and with this, I'm getting the file. This the get file function will get me the complete blob of the file, and I can set the URL it's create, and I can use it in my browser. Yeah, but we cannot see it. It's in the browser's environment. You cannot like go to a file and find in your file explorer. It's not visible. Yeah, it's not. Yeah, it's in browsers. It will count in browsers memory. Let me show you this. So, if so, here this is the same approach I am using. If I select a file from here, let's say maybe a window. Let's say watch a movie at 10, and I insert this. So this file is in my browser now. This is we can view this file from this. There's an extension, Chrome extension present, which is called as OPFS Explorer, through which we can see what all files are present in my OPFS right now. So if you can see, there's this the file I have uploaded. I have an ID corresponding to it here, and inside my IndexedDB for this file, I have stored this ID inside a IndexedDB array. So this ID is nothing but the file name over here. So in the previous slide, which I was telling this, I'm using this file ID to get the file from the IndexedDB. And if you can see in the page memory, we are not like, it's not present. So if we go in the cookie and site data for our, so over here you can see our site has using 1.6 GB of storage, which is like this the page storage as well as the OPFS storage. Also, if you want to see how much storage is used by our file, you can go to application. Inside storage, you can see the amount of storage used by file system, which is nothing but our OPFS, and the IndexedDB, how much storage is being used by IndexedDB. Yeah, so OPFS, one thing, as I said, it's great for file handling if you want to store multiple files as well as manipulate those files, change frequent read and write stuff. So OPFS is the go-to tool. It's recently launched, like in 2021. It's been launched. Uh, yeah, coming back, this this is the same. If it's efficient for layer storage, fast local read and writes. We can get this access to OPFS like offline. We don't need internet. As well as this is same to our origin. We cannot, like, other files cannot access, other origin cannot access these files. As well as this is we can use this in web workers, service workers, as well as wherever we want. Yeah, it's supported by most of the common browser, but the storage limit is like the Chrome has the largest one, but Safari has the least. It gives around like 1.5 GB storage limit to this. Yeah, yeah. The media is stored in my IndexedDB, and inside that there is an ID key present, which is nothing but a file name of my file. So I'm just displaying the complete list in my application. So this is inside an array, a simple function. Function will get a media at the top, and I'm iterate on all the files on IndexedDB. Yeah. So one of the like most used use case of OPFS currently is OPFS has a out of the box support with SQLite when we want to run SQL queries inside our browser environment. So SQLite is the most popular most one of the most popular tools. Like if you have worked with a mobile application, you must have used SQLite to store files, to get the files stuff. So this SQLite has a wasm build itself. As you can run the SQLite inside browser, and and like basically SQLite is a, it stores all its databases inside a single file. So with this, we can use OPFS over with this file. We can store the database file inside our OPFS storage. We can create tables. We can like query from that OPFS. We can, as this is a faster read and write, we can use we can keep this database file inside it. This, no, this I'm talking about a browser environment. Yeah. So if we talk about Redis, it will go to again a API server. Yeah, caching DB. Correct, correct, correct. So basically, if we get this hands on, so basically, this is my. I've created an application which uses SQLite Wasm plus OPFS. So if you, so I can import a DB file of it. So with SQLite, you get a database file like this. This is a simple, these all are SQLite files, other different kinds of databases. I have two dummy databases with me. So let's open this. So this is a 240 MB database file I have. I can list table what all things are there in my SQLite. So basically I have run a select star command for this. So if we want, so I have a table named as people on in here. So if I want, it basically runs a SQL query with, and this whole thing is happening inside a web worker. So our main thread is not stuck. Uh, it will come eventually. Let's see, select star is a heavy operation. Let's do a count star. Oh, it came. There are like around 20 lakh records, and we can, yeah, the main issue is over here performance. Like if we have a complex complex database, lots of table, we have to do a lot of join, then we might have to wait for some time to get the output, like as we seen with the select star. uh, the same we can, like this is a smaller db, but let's say if I import a bigger db, I have a bigger db example over here. Same, I copied the DB file inside my OPFS, and with that, and with this, with my origin, I can access this OPFS. I can list table, what all tables are there. I can run queries on this. Let's say title. Yeah. Yeah. So basically, if we want to store all this, we want to use this functionality. It's like I give you a use case of Notion, like as Bruce suggested. Notion uses this OPFS approach with SQLite WASM. How many of you are aware about Notion? What Notion is? Yeah. So basically, it's a management tool, a task management, or also stuff like that. So to make their first data load fast, what Notion does is they store everything, every changes which we do inside this same file. Let me open Notion itself, like it will be clear. Yeah, it is supported in mobile browsers, but same, the storage quota is limited in that. So you can see inside in Notion website we have this OPFS root, and this they are going one level deep. So this is a DB SQLite database file which we have. For my use case, I haven't done any storage or anything, any media, nothing. So it's small. So what they do whenever I refresh my page, so they run a SQLite query in this database. They get the data, they display this. They call the API again and they update this database. So, and whenever I have changed anything, let's say I am marking this as done. So they are updating the database over here, as well as they are sending a update request to the cloud database as well. So they can keep both in sync. So if I go offline, I can use this database itself, and whenever I come back online, I can like sync with the database, sync with my cloud database again. Hmm? Yeah, yeah. Yeah. It's quite new, right? So maybe in future we'll have a other tab for OPFS as well, because the file system is like evolving. Like earlier, without this OPFS, we have the approach for file system, but we have to keep requesting user for like, I want to see this file, I want to see this file, like this. But yeah, in future maybe we can get the support for, we can get a dedicated entry inside the applications tab in browser. Sure. So this is how WebAssembly. So SQLite it's written in C language. So we converted this to a WebAssembly build, and this WebAssembly build is been like given by a, let's say, a package or something, and we have imported this in our application memory and then running it inside a web worker. So this is how we are doing. So let's say a URL is requesting the query. So this query we are sending as a message to a web worker, and this web worker is running SQLite. This asks for a database file. It gives this database file. It returns the data JSON back to our page with a message, and then again update if there is no select, if it's a update query or something, it will again update the database inside our OPFS. So talking about the potential use cases, same, the caching data for enhanced user experience. So similar thing which I explained like about the Notion scenario, they use this SQLite to store. It's like nowadays this local first approach is like quite popular. We have to, if you have heard about linear is a like kind of Trello or something, manage product management, create task, bug list, and stuff like that. So Linear uses this local first approach. They're not using OPFS right now. They use something called as DuckDB. DuckDB is similar to SQLite. It runs query on our browser, but it uses inline in page memory, so it's limited in memory storage. Um, Other than that, this we can see in potential use cases, we can have a completely in-browser video editing softwares like we do not have to install any application. We can just like do editing in our browser. We have browser, we have editors in Windows, video editors, audio editors right now as well, but they all are connected to some kind of database where we upload a video to their servers, and then chunk by chunk they send us a video. We can update a frame, do things like that. But with this we can limit the use of database local storage. We first edit it, and then we can sync the web media to the browser. Yeah, it does. Yeah, but it's, if you have a memory available in your laptop, then it's similar to a file storage, like, right? And one more use case which can potentially use this OPFS as like using this LLMs inside our browser only. So basically, we download this LLM. Like again, these LLMs can be huge, but if there are small LLMs, we can download this and store it in our OPFS, and then same with the WASM, we can communicate with this LLMs, and we can get the data and stuff, everything like that. So yeah, this is pretty much it about PFS. Any questions so far? Yeah, yeah. Own. No, the extension cannot use it. Yeah. Sorry? Yeah. It will if we give a file name, different file name. So basically, it's same as your local file system, right? If you download same file twice, one approach they use is they keep 1, 2, 3 in the file name. We can do the same thing. No, we have to like, do it manually. We have to change the file name. Yeah, it will replace. If you give same file name, it will replace the same file. No, if you are at a particular origin, you have a read-write access to OPFS. So basically, if for my origin, I have created this file, I have uploaded from my origin, then with this origin only, I can read it, I can write it back again. So yeah, there are lock mechanism in this. Like basically, we can lock this file, do not change it, do not like. There are stuff like that. Yeah. Yeah, the it will go to catch. Okay, thank you.